Jenny, can you pull this down, please? Ellen,
He's gonna do it. He's gonna do it.
can you pull this
No,
down,
he's gonna
please?
do it. He's like, oh, he's off.
Ellen. They're too lazy. Thank you so much. Well, fine. Hello, everyone. How are you guys doing today? Last time I thought I made a mistake, but actually I didn't make a mistake. And I feel so stupid. Like, oh man. Yeah, it was odd, but I didn't realize that. Man, yeah. So, in our last class, we started 1.6. Come on, how come it's not working? Okay. We started 1.6, and if you remember, we talked about add function and even function. We said a function is odd if we have f of negative x equals negative f of x. Basically, it means if you change from positive x to negative x, your y will also change from whatever y to negative y, then it's an odd. And for even function, a condition is f of negative x equals f of x. Means the positive x and the negative x, they're supposed to give you the same y value. If you don't have the same y value for both x's, then it's not. If you have same x value, same y value for both type of x, then it's even. And if you have their sign different, then they're odd. And if none of the conditions satisfied, then if I have a function that is neither odd nor even. And we did few examples, and we showed by replacing x with negative x, you're comparing f of x with f of negative x with negative f of x. You compare these three things and figure out are they odd, even, or neither. Then we did some transformation, and in the transformation we said if you have a number after your function, so you see the original function and you're adding a number, means you're moving up. If you're subtracting the number from the function, you're moving down. However, if you have a number inside your function, you're adding, so inside means you're moving in left or right. So let's supposed to be minus, but actually it doesn't follow. If you have a number plus inside your function, you're moving left. If you have a number minus inside your function, you're moving to the right. And then reflection, you have two types. All these times we see a minus f of x. When you have a minus in front of your in front of your function, there is a reflection about x-axis. However, if you have a minus sign inside your function, in front of x, then it's a reflection about y-axis. And then we did few graphing examples. The last thing we did was, instead of using transformation, how can we graph polynomials using the sign for the y based on the x? So the methods I said, find x and y intercept, plot them on x and y axis. And now between every two x and y intercept, find some number, some y value, and then figure out based on the y value whether your graph is lying above the x-axis or below the x-axis. So one of the easy way to do it, instead of finding sign for every interval, you can actually find the sign in one interval, and then you can decide the sign of the other without doing any math. How? It's based on the factor. So step one, factor your polynomial completely. If it's factorable. If it's not factorable, then you cannot use this method. But if it's factorable, factor your polynomial completely, and then from those factors, solve for x. Basically, you're finding the x-intercept. When you factor, you look at what's the power of the factor. Is it an odd power or even power? So when you get the x-intercept from each factor, The x-intercept you get from the factor, if the factor has an odd power, the sign will alternate on the left and right side of your x-intercept. But the x-intercept you got, if it's from a factor that is even power, then for that x-intercept, you're going to have the same sign on the left and the right of that x-intercept. And then based on that, you just alternate your sign. For example, let's start with something easy. We have y equals x with the 1 power, x minus 1 with the 2 power, and x plus 2 with the 3 power. So you have 3 factors and they have their individual power. So step 1, solve for x-intercept. So our first factor is x. You set the factor equals to 0. And it's already solved. We don't have to solve anything. So it's already solved and it has an odd power. We have an odd power here. So our sign will alternate for this x-intercept. The next one we have x minus 1, 0. So x equals 1. But this x equals 1 has an even power. We call them actually multiplicity. X equals 1 has a multiplicity 2. So it has an even power. So sign will not alternate. Sign, I could write same sign. Means to the left and the right of that x-intercept, we are going to have the same sign. And here you're going to have a different sign. Means before x equals to 0, whatever sign you have, after x equals 0, you're going to have the opposite sign. So the sign will change for x equals 0, but sign will not change for x equals 1. Why? Because x equals 1, x minus 1 has an even power. The last one, we get x plus 2 equals 0. That gives us x equals negative 2. And what's the power on the negative 2? Sorry, the factor for the negative 2? It's the odd power, right? X equals negative 2 is coming from a factor that is an odd power. For odd power, we get different sign. So if your factor has odd power, then for that at that x-intercept, we are going to have two different signs. One is on the left, one is on the right. The sign will not be same. But if your factor is an even power, then at that x-intercept, on the left and right of that x-intercept, we are going to have the same sign. This is odd, so our sign will be different. Once you know these rules, then you can draw your graph easily. Oh, we have negative 2, 0, 1. Okay. So this is x, this is y. We have 3 x-intercepts. One is at negative 2, one is at 0, and one is at positive 1. Right? 3 x-intercepts. 0, I should box them. 0, 1, and negative 2. So negative 2, 0, and 1. Now negative 2 has an odd power, so our sign will be different. Now you have to know what sign we have. So you have to pick only one interval. Either pick this interval or this or this or that. Pick any one interval and figure out the sign. For example, let me take this interval, the last interval. Okay? Pick any x value, let's say negative 4. When x is negative 4, what's the y value? Our y is negative 4, negative 4 minus 1 square, negative 4 plus 2 cube. Negative 4 gives us negative Because of the square, this term will always be positive. So the middle sign is positive. And now we have negative 4 plus 2 is negative q. Negative q going to give you a negative. We are looking at the sign. We don't care about the number. We only need the sign. So if you multiply 2 negative and 1 positive, what's the result?
Positive.
Positive. So when x is negative 4, you have a positive y value. So your y is above the x-axis. It's positive y value. Now at negative 2, we are going to have a different sign. Means whatever sign you have before negative 2, you are going to have the opposite sign after negative 2. So before negative 2, a plus sign. After negative 2, we're going to have a minus sign. So your y value will be here, below the x-axis. Negative 2 has 2 different signs. Why? Because the factor x plus 2 has a cube power, which is at. We're doing this so that you don't have to check every single interval. If you don't understand this, no problem. You have to check every single interval by picking some x value from each interval. Now at 1, so at 0, we have odd part, so the sign will alternate. So before 0, we have a negative sign. That means after 0, we have to have a positive sign. So we are going to have a positive y value here. So at negative 2, sign will alternate. At 0, sign will alternate. But at 1, the 1 is coming from x minus 1 square. Square is even numbered. So at 1, sign cannot alternate. Before 1 and after 1, we have to have the same sign. Are you guys okay? Did you understand what I'm doing? No? Okay. So step 1, solve for x. Did you understand this part? Now when you solve for x, you have to look at your vector. For that x value, what's the power of the x? 1. For this x equals 1, what's the power of this vector? 2. 3. For x equals negative 2, what's the power of this vector? 2. Now the rule says, if you have a x-intercept that comes from odd power, then before and after that x-intercept, we are going to have 2 different signs. It means 2 different y values. But if the x-intercept comes from an even power factor, then the left and right are going to have the same sign. So we have 0, 1, negative 2. Replace them. Negative 2, 0, 1. 0 and negative 2, they have odd power. So they're going to change their sign before and after. So I picked only one interval. I picked here. What's the sign for the y value at this interval? So I put in x value negative 4 and substitute into the equation. And we found our y value is positive. That means our graph is here, above that x-axis, positive y. Now I don't have to check every single interval because I'm going to use this method. This is coming from odd power. So whatever sign you had before, it has to have the other sign after that. So this is plus, it has to be minus here. For y at the end, 2. Here we have another x-intercept 0, right? And 0 has what power? Odd. So whatever sign you had before 0, it has to have the other sign after 0. So before 0 is negative, after sign has to be positive. Then we have our next x-intercept, which is 1. But 1 is coming from which power? Even. So you have to have the same sign before 1 and after 1. So this is our graph. Now all you have to do is draw them, connect them.
I kind of get it.
What you don't understand? Like which part?
Why?
Why the graph is like that? Did you understand the rule? Okay. Did you understand the x-intercepts? Now, how are you going to graph it? We need the y value, right? So find any one y value. I found this y value. When x is -4, what's the y value? Positive. So it's lying above the x-axis. So our graph has a shape something like this. The left side is going up because all the y values here will be positive. And then you have to cross your x-intercept. So you cross your x-axis because this is your x-intercept. You have to cross it, right? X-intercept, you have to cross it or touch it at least. Now, this -2 coming from a power, coming from a factor that is an odd power. If you have an odd power, your sign has to change when you cross. So here you have positive y. When you reach here, you have to go down. You have to change your sign. And once you are here, now you have to go back up because you have another x-intercept. So you're going up. Now this x-intercept coming from a factor that has 1 power, which is odd. That means you have to cross it. If you're coming from an odd power, you have to cross your x-intercept. Okay, you must. So we have to cross it. When you cross, so y is negative here, but y is positive here. So you're going here. But it cannot go on forever. You have to come back here. It doesn't matter how far you go. At some point, you have to come back at 1. I'm not sure about this. How far these are going, I'm not sure. I have no idea. What I'm doing is I'm just connecting all those intercepts. Now, this one is coming from a factor x minus 1 square. So 1 has factor 2. Sorry, that factor has power 2.
So the same.
So you have to have the same sign before 1 and after 1. So how can you walk here so that you have same sign on both sides? Can you cross here? You cannot, because if you cross, your sign will change. But you cannot change the sign. So what can you do? Just touch it and then go back up forever. So you're crossing here and there because they have power add. We call them multiplicity. These two x-intercept have multiplicity 1, multiplicity add, but this one has multiplicity even number. And since this is -2, it actually will lie a little bit on the floor. It will go this way. The higher the degree is, the more you lie down on the axis, on the x-axis. So 1 has x equals 0 has 1 power, it crosses directly. X plus 2 is a 2 power, so at -2, you're going to lie down a little bit, and then you're going to cross the x-axis. X equals 1, you have even power, you cannot cross the x-axis. Okay? So for even power, you can never cross the x-axis. You can only touch it and then go back to the same direction. For odd power, you have to cross it, and depending on what power you have, you cross differently. If you have, let's say, x to the 1, you cross this way. Sorry, I'm going through 0. You cross this way. But if you have x cubed, then you cross this way. Then if you have x to the 5, you have to lie down more, and then you cross. The higher the powers are, the more you stay on the x-axis. That's the rule. So the cubic graph is a little bit on the x-axis and then crosses. But fifth, it lies a little bit more down and then crosses. Like the higher the power, the heavy they become. So they have to lie down a bit to get their strength. Any questions? So this is what you do if you don't have any other information besides x-intercepts. But later we are going to learn more information. So life will become much easier. But using this concept, what we did in our last class, we had a polynomial that is not completely factored. So step one, factor completely. So when you factor completely, we get two factors here. And by using AC method, we get two factors in the second factor. That means whatever is given here is same as whatever we have here with these four factors. The blue one is completely factored and the red one is not completely factored. So step one, factor completely if possible. So you factor completely and then you need to find your intercepts, x-intercept. So x equals 40, 2 minus x0, 2x minus 30, and x plus 1, 0. All of these, they have odd power, so they are going to cross and their sign will change. The only thing doesn't have odd power is x to the 4. So we cannot cross our axis for x to the 4. When you solve x to the 4, what x will we get? If x to the 4 is 0, what is x? 0. So this is the only place you cannot cross and you cannot change your sign. So not crossing the x-axis. You cannot cross the x-axis because it's an even power. For even power, you cannot cross the x-axis. From here, our x is 2. From here, our x is 3/2, which is 1.5. And from here, our x is -1. So we have 4 x-intercepts. Let me do it here. One is, so we have more on the right side. Okay. This is x, this is y. We have 0, 1, 2, 3, -1, -2. So this is -1, this is 1, 2, 3. So at 1.5, there is 1. We should put 1.5 a little bit to the left. 1.5 and 2. And what else we have? -1. Okay. So -1, 0, 1.5, and 2. 4 x-intercept, we plotted them on the x-axis. And now we pick any interval and find the y value. Which interval you want to pick? Any interval is fine. The first one, the first interval, second, third, fourth, fifth. First, so pick anything that is smaller than -1. -2. When x is -2, what's the y value? -2 to the 4. 2 minus -2. I have done space, so let me do it on the right side. Okay. X equals -2. Y is -2 to the 4. 2 minus -2. 2 times -2 minus 3. And then -2 plus 1. I'm using my factored form. -2 to the 4. What power we have? Positive. 2 minus -2. What power? What sign we have? The minus and minus turn into plus, right? So this is plus. We have -4 minus 3. What sign you have? Negative. -2 plus 1. Negative. So when you multiply all this sign, you get positive. That means here our y value is positive. So the only place that we cannot change our sign is before 0 and after 0. So before -1, we have positive y. So this is what is happening. To change the color to full. Before -1, our y is positive, so it has to lie above the x-axis. -1 has odd power, so we are going to cross. Then we reach at 0, but 0 has 4 power. We cannot cross. So what do? We just touch and come back. And then 1.5, it has odd power. So we cross. And then it doesn't matter how far we go, we have to come back eventually, right? Because we have an intercept at 2. Can you cross the 2? We must, because 2 is coming from an even odd power. So what is happening here? Plus here, minus here, minus here, minus here. So this is minus, this is minus. The sign did not change for 0 because 0 is coming from an even power. Before 1.5 it's negative, after 1.5 it's positive. So sign is changing. Now before 2 the sign is positive, but after 2 the sign is negative. So this is what it means, the sign changing or sign doesn't change. As long you don't have to remember the sign if you remember the rule about the multiplicity. If your intercept has even multiplicity, it cannot cross the x-axis. If your intercept has odd multiplicity, then you can cross. Are you guys lost? No? Who has a question? Anybody? Why the last one is negative? Because at 2, we have 1 power, right? 2 minus x has 1 power. So when your intercept has odd power, you must cross the x-axis. So before 2, you're above the x-axis, and you have to cross it. So when you cross, what's the y value below x-axis? What's the y value above x-axis? Positive. Below x-axis, what is your y value? Negative. So since you have to cross the door, you have to cross the door. This is your door, okay? You have to cross the door. So from positive, where you are moving now? Negative. The sign changing. If your x-intercept is coming from odd power, you cannot cross the door. You just knock on the door and you just leave. For example, here. Your graph is knocking on the door at 0. I cannot cross, it just comes back after knocking the door. So let me write the rule down. X-intercept has odd power must cross the x-axis. X-intercept is coming from an even power. Then it cannot cross the x-axis. Not the power on the x-intercept, it's the power on the factor you have for that x-intercept. Is there anybody who is still lost? No? Okay, then test yourself. See how much you understood. Graph this one. So let me take that. . 。 Today is 10-3. Dominica, Salahuddin, Arsla, Maxine, Zoe, absent. Jolene, Prince, absent. Hayden, here. Ellen, here. Asir, absent. Skyly, Alice, Jasmina, Alexandra, Jennifer, Jessie, Johnny, here. Hafiz, absent. Tarin, absent. Pedro, here. Erika, here. Jawad, here. Ruby, Sayom, absent. Dimitri, here. Dimitri, are you sleeping? Dimitri, Siki, here. Amir, here. And William. 1, 2, 3, 4, 5, 6. Wow, 6 absent. Okay, I'm curious. What distance? Morning on. Of course not. How do you factor someone?
What?
How? It's so for this way.
Wait, is that how we're supposed to do?
Sure, fast. You have to
Oh,
focus.
same.
You must factor. So, first I'm going to help us. I just did that in that zero with. Did you have to? How far is this hunting the minute? Go ahead, then. Look at the next one. Okay, let's do negative square. Then how far you do negative square? Negative x square, right? No, it's not negative x square. What am I just square? That's not better. Good. Can you factor this more? Can you factor this more? Use. Perfect. No, factor this more. So x comes down to the minus 5. What is that? One. So it's just, I said factor first. So the 6 will factor in. So or you cannot take square out. Because 24 doesn't have square, 24 has only x. First to check. How do you get x equals 5? So how did you get x equals 5? How? What did you do? So So from this line, how do you get 5? Good. So your x squared equals 25. And what is x? What number square is 25? 25? 25?
I have a negative 5.
What a negative control. From this correct smooth square. So your number 5 is like 5 quadrants and how do you
Should put that in person. Wait, do you just like back them more?
you can factor more. That was the purpose, factor ones. So I don't know the one that the negative 6 0 into the 1. So also why you make it? Negative 20. So you don't need any actual conversion to change the form. You can just use that. That's the factor, so that is the negative. So when you use y, you're not looking at the numbers, you're looking at all the sign. These times are going to want to use something like that. So you're going to do math like hands. And then you put them to watch the time. So you place negative 6, negative 6, what's the mean of it? And the 36 plus 5 is the mean of it. This is that on the side. What is the point? My first question, did you get factor class? What was factor class? So, options we have the x and prove that correct. Solution of x which d5 minus x squared.
Interesting. What?
What do you think the scale from 2x, dx, and what is that?
We just copying it. These ones copying it.
Yes, factor 1 is beyond the consider solution, but 45 is something with the public squares. But if you don't see the factor, then you can from where you're pushing, where you're discounting. So this is how I factor 1, the tragic factor motion. Yes, we factor factor 2 to which. And then you're taking one insertion. And I'm going to take your phone if you're using it one more time.
Not very
If I see you using one more time, I'm going to take the phone.
So just like
So you even chose negative 6.
yeah, yes. So we
Now-
plug it into this. Then I got one negative. So it starts from negative.
So negative, 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 3 negative.
Yeah. So it starts from negative.
3 negative is positive or negative.
Negative.
So it's down, right?
Yeah. So this.
And no, you're crossing the negative 5, right?
No.
6.
Wait.
Your intercept is negative 5, so your
Wait.
door is negative 5, right?
How do you draw it? Oh. Yeah, no.
You have to go through your door, your door is intercept.
And negative 5 is R. So you go
You have
up.
to cross.
Wait. You go up.
And then the next one, 0, which is add.
R.
So it's go down.
R 2. Easy. It's so easy. Like where?
You cannot
Like where?
you cannot figure out that square. Because x has so you have x as one is square. So I'm gonna go this square. Take solution of 1 of it. So you pull out on x with x square. The smallest number is x. Definitely. As a result, you get 25 here and then minus square here. The 3 becomes 2. This one is more factor of 3 times. This is 5 square minus x square. 6, 5 square minus x square. So it's a difference of 102. It is the factors of the conjugates. And conjugate is they are actual and subtraction. So 5 plus x and 5 minus immediately x. So this is completely of future. And I use these to get back to the set and then find one.
I don't have
One
one. Yeah.
Why you do that process from 5?
No, at least.
What's the plot?
Yeah. Ah. Yeah. Yeah, airplane.
So what number you have chosen? So okay, so if you take 6, so it's 18, so this is how
You who
this
that's just one.
so you got like minus x, so minus positive, and this so negative. So this is
So they gave stuff. They gave that. Check it out. Oh my god. I'm done. No, wait, you want to think of it. He's on his phone. He's on his phone. Yeah, I mean, they all get a fan. No, just going. What is this?
fucking negative, so very top. Wait, you're hard to yourself.
Yes.
So positive is here.
Yeah.
So you need
Total age. Jack shit.
all these.
So that's like 1 hour by fucking.
You want to compare the.
That's 1 hour by.
Check.
Yeah, why? You don't earn that. You don't earn so much. 1 hour, bro. 1 hour my life wasted on this fuck out 55, man. Oh, yeah, you don't. Yeah. So that's more than the hours of like after taxes.
No, because plastic is
Like get paid 16.50, but after tax it's like 14.90.
oh, Johnny, no.
I got it wrong. How?
How this is negative and then
Negative. Look, negative, negative, negative.
this is not negative, it will be just
Oh shit, that's positive. That's
yeah.
Yo.
Yeah.
Yeah.
So for this question, we have x in common, not x squared. We can factor out x. And what is my okay? You factor out your x and you get 25 minus x squared. Now 25 is 5 square. So this is actually difference of perfect square. So their factors are to conjugates, the addition and subtraction of the bases. So your final factor is x, 5 plus x, and 5 minus x. You should always factor completely because if anything has an even power, you need to know, does any of the factor have even power? Once you have this, then you're going to find intercepts. X is 0, this gives you x is negative 5, and this gives you x is positive 5. So we have negative 5, 0, and positive 5. So this is x-axis, this is y-axis. And then you pick any interval, anything is fine. So you can pick the last one. Let's say you're picking when x is negative 6, what's the y value? When x is negative 6, our y is negative. This becomes positive. This is negative, and this becomes positive. Because 5 minus minus 6 will give you positive. This is 5 minus 6, and this is negative 6. So negative, negative, and positive. Your answer is positive. So you have a y value above the x-axis. So that means you are starting your graph here on the left side, and you have to cross negative 5 because all these intercepts, they're coming from odd power. X has odd power. This factor has odd power. This factor has odd power. All of the factors, they have odd power. So you have to cross on every X intercept. So you must cross at negative 5 and then go up to 0. And you cannot just knock and come back. You have to cross it because it's odd power. So then you have to come back at 5 and you have to cross it because 5 is coming from an odd power. So this is your final answer. It's rising on the left, going down on the right. Any question?
Why is it going down? Yeah.
When you're crossing your 5, can you go up again? Do you have any other x-intercept after 5? After 5, do you have any other x-intercept? Then you have to must go up. There's no way you can come back. If you have more intercept, then you have to come back to cross it or knock it. But you don't have anything. Mm-hmm. So at the end, you always have to either going up or going down. And this is true for any polynomial. All of these are polynomial. Do you remember what is polynomial? They don't have any negative power. They don't have any fraction power. No variables on the denominator. They have only positive integers. No fraction, no negative, no decimal, nothing, only integers. So now we know how we check our graph in the middle. But what if we don't want to find the middle? We only want to look at the end. What is happening only at the end? See here, this example, the left is up, going up, the right is going down. That's the end. Previous one, the left is going up, right is going down. What if we only care about the end? We want to know the end result. Eventually, what's the direction? So that's called end behavior, how the graph is acting toward the end. And we can find them easily by remembering four rules. Okay. These are the 4 rules we have. Based on your coefficient and the highest degree, we can easily figure out their end behavior. Now let's say you have a positive coefficient with even power. Example, x squared. We have a positive coefficient, which is 1, and our degree is 2, which is even. So positive coefficient, positive, these are coefficients, okay? Coefficients. If you have positive coefficients with even power, example is x squared. What's the shape of x squared graph? Parabola. So observe what is happening at the end. The left side is going up, the right side is also going up. So the end is going on the positive side forever. So the end behavior for any positive coefficient with even power, the left and right, they both have to go up, upward forever. The second type of function is negative coefficient with even power. For example, negative x squared. What's the shape of negative x squared? Upside down parabola. So observe the ending. The left is going down, the right is going down. So it doesn't matter what type of power you have. If the coefficient is negative, and if you have the highest degree is the even degree, then the ending always will go downward forever. So you don't even have to memorize anything. Just remember the shape for x squared and x cubed, and you know your answer. So the first two, either positive coefficient or negative coefficient, but they both have even power. So anytime you see even power, remember your x squared and imagine your graph parabola. You know the shape, the ending. The third type is positive coefficient with odd power. For example, positive x cubed. Do you remember your cubic graph? This is the shape of a cubic graph. For x cubed, what is happening on the left side? Going down, and the right side going up. So for any positive coefficient with odd degree, the left will always go down, the right side will always go up. And now the last type, what if we have negative coefficient with odd power? So negative coefficient with odd power. Do you remember your negative cubic graph? It's just a reflection of this graph. So the left side is going up, the right side is going down. So any odd power, odd degree polynomial, if the coefficient is negative, then the left will go up, the right will go down. So that's how we read, like the way we read, left going up, right going down. But this is not mathematical term, right going up, left going down, this. The professionally, mathematically, what we say is we use the infinity symbol. For example, here, any type of even degree with positive coefficient, the both ends are going up. So we say when x goes to negative infinity, means when x is going to the left side, our y is going to the positive infinity, means y is going up. So when x is going to the left, y is going up. This is how we professionally say and behavior. As x is going to the negative infinity, this is infinity, not 8. Or y is going to the positive infinity, which is moving upward. And now to indicate the right side, we say when x is going to the positive side, which direction our y is going? Same infinity. So this is what we write professionally, mathematically. But in professional way, we write left going down, right going up, or right going down, left going down, like those things. But when someone says using mathematical notation, state and behavior, that means you have to use the infinity symbol. So that's all. If you can remember these 4 pictures, you know the end behavior for any graph. And this is to blurry. But this is what's the square graph, positive coefficients, even graph, negative coefficients. Cubic graph or the odd graph with positive coefficients, odd graph with negative coefficients. And that's how you write the end behavior. Now let's do some example. But before that example, do you even know what's the power of the polynomial or degree of the polynomial? Do you know the rule? No? Then I should have written this before. I have it somewhere. Degree of the polynomial. If you have a format like ax to the, let's say, n plus ax to the m, bx to the m, plus cx to the mno. No, what doesn't look right? Like this. Like if you have many powers and it's not in factored form, then your degree is highest power. Okay? Between, not between, among all those powers, whatever is the highest number, that's your degree of the polynomial. However, if you have a factored form, if y equals, let's say, x plus a with n, x minus b with m, let's say x minus c with p, then in a factored form, or let's say I have a square here, then in the factored form, your degree of the polynomial is this. You take each factor on the x and you multiply with the outer degree. So this x is 1 power, 1 times m is n. Oops. Then you add the next one. This x has 2 powers, is 2 times the outer degree m. So it's 2m. Plus this x is 1 power and outer degree is p. So it's 1 times p power. So in a factored form, your degree is the sum of all the degrees. The individual degree plus the degree you have on the x. But when you're not factored form in general form, it's the highest number you see. Okay? That's how we decide to. Why do you care degree? Because all these rules, they depend on the degree. What's the degree of your polynomial? Now here our life is easy because it's not in factored form. It has the individual power. So you look at the highest number. What is the highest number you see on the degree on the power? 5. So degree of the polynomial is 5. And now whatever has the highest degree, that coefficient is the coefficient we are looking for. So highest degree is 5. What coefficient it has? The 5 degree has what coefficient? -1. So coefficient is -1. We call it leading coefficient. Leading coefficient. Why do we care? Because the leading coefficient and the degree tells us what is our end behavior. So we have a negative coefficient and an odd degree. So negative coefficient, odd degree is like cubic power. And we know the shape is negative is the other way around. Is this one. Any negative coefficient with odd degree is same as negative x cubed. And negative x cubed on the left is going up, on the right is going down. So the end behavior for this, even though it doesn't have a cubic power, it's fifth power, but it doesn't matter. It follows the same rule. The left is going up, the right is going down. And behavior. So I have to write it professionally. So we write as x goes to the negative side, means here, when x is going on the negative side, which direction our y is going? When x is going on the left side, our y is moving to infinity side. So this is the left hand behavior. Now the right end behavior. As x is going to the right side, so x is going to the right side, how y is moving? Downward, negative infinity. So this is means left, and this is means on the right side. So this is a visualization what is happening, and this is professional way. Correctly we write. Who is last?
How do you know what's formulated?
Even any negative coefficient with odd degree will follow negative cubic shape. Negative coefficient with odd degree, it doesn't matter what degree we have, as long as the coefficient is negative and its degree is odd, it will follow this shape, negative x cube shape. So what's the negative x cube? This one. So the left is going up, right is going down. Means on the left side, x is going to the negative infinity, but y is going to the positive infinity. On the right side, x is going to the positive infinity, but your y is going to the negative infinity. This is what you wrote here. Any other question? Okay, then you try. 3 of them. And do I have more? No. 3. Write the end behavior. Find the end behavior for this. Instead of 3, let me give you, let's say 33. And let's say this is x to the 5. Okay. Find the end behavior of these 3 polynomials. Oh, Sion is absent, Sterling is absent, Operator is absent, Kashid is absent, Prince is here, Joey is here. Okay. So what is this direction? So what do you write? Same for the X is going to the right side, right? So X is positive direction. But Y is going to the left. Good. And how the position go? So going to the negative, the beta
Oh God.
so we're seeing the constant total all the solutions.
33 of God, and yeah, with that, it's not the beginning. As if it's a big for all significant things. Just start. Showing.
What's it? It was like 1.5. Negative 3%, which taking surface. What is that? Was should have movement. When you see it, again, power. Picking is on. Any given powers are still the same shape. That's it. So here we have negative coefficients, given power. So what type of graph you know, or what type of polynomial you know that is given power, and you know it's graph. There is one given power graph you know, because there is one thing. So it's just nice. So easy. So what you have also leave, and you see the company and so what you also have a C. What's the empty? The both are going to the empty. So it will be the same empty. So you look at every graph and square them. And every other type of even though we follow history. So it's really huge graph and so that. And what was one is negative x squared, complex shape for negative x squared. What's the one x squared? See? Why give me some clear from India Australia? You have to remember the two shapes, square graph and cubic graph. What's the shape of square? Square. Square graph. You did it as well on that. X square you have one. And then you negative x square, so I can from. Do you know your cubic graph? The shape of the cubic graph. Cube is this. Cube graph.
She's asking, that's why I was asking, like,
You need to remember this shape. Why? Because every other graph was the same and empty. For example, here you have negative slope. That means they're going to follow this one. That ends will go downward on both sides. This is 4 power, which is even. every event of being at the end. Okay? So at the end, you look like this. And now you express this mathematically, you write, well, on the left side, your x is going to the left side. X is going to the negative infinity, y x is going to the negative infinity, and y is going also to the negative infinity. Right? The x is going negative infinity, and y is going down infinity. This side, your x is going to the right side. So we write x is going to the positive infinity, and when x is going to the positive infinity, then y is moving down. So the y is moving. So step one, whatever it has, relate that with a quotient symbol. And placing the whole things to the right something. Please, we don't have time, so let's go start by them real quick. What's the degree of the first polynomial? 4. And what type of coefficient we have? So it's negative x square shape. So the end will go down. So this is a negative coefficient with even graph. So when x is going to the negative infinity, y is also going to the negative infinity. It's the left side. The right side, when x is going to the right side, positive infinity, our y is still going down. So y is going to negative infinity. That's the right side. I don't have space. That's why I'm writing this there, but you should write from left to right. The next one, what type of graph is the next one? Add or even? Add. And what type of coefficient we have? Positive. So let me change the color. Red. No, not red. Slow. We have positive add, right? So it's like cube, x cube. So the left side, x is going to the negative infinity. How y is going? Negative infinity. And on the right side, when x is going to the positive infinity, which side y is going to? Positive. So this is the second one. The third one, what type of graph is the third one? Even and coefficient? Positive. So positive even means like x square, parabola. So the left is going up, right is also going up. So when x is going to the negative, y is going to the positive. When x is going to the positive side, y is also going to the positive side. So this is left and this is right. And that's how we find the end. Why do you care about the end? Because every graph has to go somewhere, and you're looking for where actually it goes at the end. Okay. So in our next class, which is Tuesday, we are going to know what is happening in the middle. Okay. We know the end. So now you're looking for the middle. What is happening in the middle? And this is 1.6. Start doing your homework on 1.6. And remember, you have your homework due 1.5. Tuesday midnight.
I just got my code.
Out.
Yeah. So can I